All right. Hello, everybody, and welcome to the stream. This is a bit of a test stream tonight. I want to give streaming on YouTube a shot. So instead of streaming on Twitch tonight, we're going to be streaming on YouTube. So basically, if you guys can hear me, go ahead and just drop something in the chat just to let me know that audio is working okay and as expected. Hope you guys are all doing well tonight. So we have a couple things on the agenda tonight. We are going to be picking up kind of where we left off, but I've done a bunch of work off camera to try and move us forward in the feature list. So we're going to basically be picking up on some work that I've done around materials, the material redux that we were sort of redoing before. And then we're also going to get back to the terrain feature, which was sort of the reason we had to sidebar in the beginning. So that's kind of the idea of what we're going to cover tonight. And hopefully all goes well. So a couple things I wanted to cover really quickly. So some changes are going to be coming. I'm trying to stream on YouTube for one thing, as you guys know, if you're watching this. And what that means is that I probably, at least for a little bit, I'm not going to be streaming over on Twitch. At least not game dev stuff for right now. And that's just because one of the things I like to do with this channel is experiment with different things. And one of those things is obviously trying the different platforms, right? So it doesn't mean I'm never going to stream on Twitch again. I'm just trying YouTube for a little bit. What that also means is that the delay between the Twitch streams and the YouTube uploading episodes that was there will no longer be there. So basically all of this content that we're doing right now is going to wind up being on the YouTube channel right away. And that just means there'll be no delay, essentially, right? Twitch does require that I have at least 24 hours of a delay, or maybe it's 48, I can't remember. I think it's 24, between when I stream on Twitch and when I release it on YouTube. And I've been trying to stick to that sort of 1 week cadence on YouTube. And this will sort of do that automatically for me, and I don't have to manage two platforms. So that's the reason I'm trying it. In addition, that also means that we're not going to be releasing something on Friday, since there is no sort of timed release, as it were. This is going to be posted right to the YouTube channel, so there's not going to be scheduled releases, right? As we stream these things, they will go directly to the YouTube channel, and that's that. It doesn't mean that I won't have any more edited content. I do have some of that stuff that I've been working on over the break, but it does mean that, at least for this main series, as I go through and stream these, they'll immediately be available on YouTube, unless we switch back to Twitch for some reason. And we can go from there. So I think that covers just about everything. See, we have a couple more viewers in here. So I know you guys aren't used to looking for me here yet. So I'm just kind of waiting a few minutes for people to trickle in. Can you guys hear me all right? Can you hear? Is my audio good and all that? It should be. It's the same OBS setup, but I just want to make sure that you guys can hear me. So if you can, just drop me a chat. Okay, so let's go ahead and jump into the content real quick. So what we're going to do this time is talk about some feature branches that we have here. It looks like I have an old stale branch, so I'll have to delete this guy. But the three branches that I want to talk about are these guys. And if you've been following along with the series, you guys probably already know what two of these are. So we have our feature terrain branch, which is where we did all of the feature work for terrains up until the point that we realized that we needed to do some material work. So what we did at that point was we actually branched off of this feature terrain and then created this material redux. And we've gone ahead and done a bunch of work in there to refactor materials to make them a lot more flexible. And one of the ideas was that we could basically provide or define custom materials in our shader config files and be able to point to those things and be able to use them without the need to edit a bunch of code. Now, there are some aspects of it that are still going to be required to be done in code, but eventually we'll get all those things ironed out as we go. So we have the material Redux branch, and I did a bunch of work in that over the break. And then we have this third feature, terrain materials, which basically is a branch, again, off of the terrain branch, which also has the material Redux work merged into it. And then we are basically combining the work that we did for the material Redux and the terrain, and we are taking those things and putting them together, and then also defining what a terrain material looks like. So that is kind of where we are at the moment. So the first thing I think I'm going to step into is this material Redux branch, and we'll have a look at that just so that you guys can see what we are looking at. So this is just a branch that I created several weeks ago, and I thought I should be able to compare this. Am I not logged in? I'm not logged in. Let me log in off screen real quick. I don't know why it logged me out all of a sudden. Two-factor authentication is always fun. All right, just wait for that to... It's especially fun when the app doesn't actually pick it up that you've requested a login. So that's neat. Let me do it the old-fashioned way then. All right. Okay, we're in. All right. So let me go back to this now that I'm actually logged in. Let's see, we wanted to look at material Redux. And then let me see. Let me actually get rid of some of these other branches real quick. We don't need the hot reloading. Just pulling this up off screen real quick. So I think the easiest way to do this is just to do a comparison between the branches. So we'll use material Redux and we'll compare that to main. And let me drag this down here. All right. So basically we have edited 12 different files, or sorry, 3 files with 12 additions, right? So there's not, oh, you know what? Did I already merge this into main? I might have. I think I actually might have already done this. So we should probably actually look at the commits. Yep. Okay, I guess I already merged this into main. I was going to wait until I actually stream this, but I guess I already did it. This was done a couple weeks ago, so I'm still trying to kind of catch up to where I was before. So, okay, I guess I can go back to main then, and let's just take a look at the last few commits. So, static naming, simple scenes. strange. It doesn't show here. GitHub, what are you doing? How is it possible? Oh, wait a minute. This is the wrong direction. That's why. There we go. Okay. That's what I was looking for. Okay. So, a bunch of things that we did. Some of this is news to you guys. Some of it isn't. So we went ahead and changed the version and all of these material files to equal 1. And we had 0.1 in there, but I decided to go with integer version numbers instead because I think kind of having a 0.1 is a little bit insane. So we have a lot of files in there for that. The other thing that we did was we defined what a custom material looks like. So we've sort of refactored this cobblestone material to be a custom material. And we can actually we can stub this out and change this to custom, and this will actually still work. So in this case, we have a version 2 material here where we have gone through, and instead of having these hard-coded names, we now have a shader that is required for custom types, or if we're using Fong, then it automatically defaults to material. We have our texture maps here. So here's one texture map, here's another one, and here's the third one. So that's diffuse, specular, and normal. And then we have 2 properties here, and this is diffuse color and shininess, right? And so this is functionally equivalent to what we had here before, but the difference is this is a lot more flexible. So if we wanted to change what shader was used here, we could change this to custom and perhaps pass in more properties or something like that. So this is going to allow us to very quickly and easily prototype shader changes going forward, at least for materials. So a lot of these other things are version changes. We also have another, this is actually a material that I refactored to be custom as a change or a test for that change. So this is a version 2 material as well. We see here that we have the type equals custom. And then that means that we also have to explicitly define the custom shader. Now in this case, we're just using the material shader, but I could pass some other shader here too if I wanted to. Again, we have 3 maps and 2 properties, right? So it's pretty much functionally equivalent of this, the version 1. It's just a lot more explicit, right? And we have a lot more power at the individual map level than we did before. Okay, more material changes. Here is a test UI material. Made a few changes to that. Most notably, the type is now UI to signify it as a different type. And we have version 2 here. So this change was actually required to actually get the game to run. So version 1 UI materials will not actually work. So there's that. And this just has a single map and then a single property, right? We have more version changes. That's predominantly what this is, honestly, is just these single line version changes. And then here is some of the meat and potatoes of the changes that we've made in terms of the material system itself. So we group all of the properties together in a structure in the shader. And in this case, we're calling it Fong properties. If we're doing PBR materials, we'll call it probably PBR properties, things like that. And then basically the whole thing gets passed in as one structure, right? And we fill out a structure on the code side, and we go ahead and pass that in. The other difference here is we have the layout set 1. First binding is for the local uniform object. So that should actually say instance uniform object. So I'll have to fix that. So this is the instance level uniform object. And here you can see where we use that structure. We also removed the float shininess from here. Okay. So a little bit further down, we just have where we tie in that properties object here and here. as well as here. So basically most of these changes in the shader are just that. The fragment shader, again, uses this UI properties. In this case, we have diffuse color, UI properties, right? And we just use the properties object there. The shader config, instead of having two uniforms, one for diffuse color and one for shininess, just has a single struct that is 20 bytes large for properties, okay? And that's going to basically be the methodology that we're going to follow going forward. So our UI shader config is basically the same thing, only UI shaders didn't have the shininess, they only had diffuse color, but we still lumped that in under a properties object. So technically the properties object for that is just containing this, this diffuse color with a struct 16 for its size, but we went ahead and followed the structure sort of nomenclature anyway, just to facilitate if we have to expand that at any point, it'll make it nice and easy. We can just plug properties into that structure and move on with life. I also ran into some issues, some memory issues while I was debugging, because I was actually, there was one point where I was basically, I think I was using a double pointer when it should have been a single pointer or something like that. I don't remember exactly what the issue was, but I added some debug code into darray. So that's what this is just some additional catches there for things that basically can go wrong. K-memory, I went ahead and I noticed that the get size alignment was not actually thread safe. And so I went ahead and made that thread safe by surrounding it with locks. And then K-string, I went through and added this string to mat4. So basically we can have a matrix 4 that's provided in text that's 16 floats, and we can actually parse that out to a matrix 4 now. And this is the header file for that. Azric, hey, welcome. I am good. How are you? Welcome to the stream. So, all right, the next thing is we had to go through all of the views and actually change them to use this properties, right? So we have the diffuse color location, that's no longer a thing. We have a properties location right now. And basically we're just, whenever we're getting the location of that, we just had to get rid of the diffuse color for this one and get the properties location instead. We also added a fix here. So whenever we go to create this object and we are trying to, I think this is in the, this is in the render. So whenever we're trying to render, if for some reason we don't actually find the material on the geometry, we were actually returning the default material, which is for the world, which contains the shininess and all that other stuff, not what we want for UI. So this just fixes a bug that gets the default UI material. And then of course, here is more location changes. That's a linting change. Same with the render view world. Not a whole lot going on here. We basically just change where we look for the transparency. So we default to false, and then we say, hey, if the material type is Phong, then we go ahead and check for transparency. Otherwise, we just treat it as non-transparent. The material loader saw quite a lot of changes to support all of the changes that we made to material configs. So we've gone over probably 90% of this on stream before this, so I'm not really going to step through all of it here. I think most of this is pretty self-explanatory if you look at the diff, okay? So there is that. I'm trying to look and see if there was anything in here that we fixed bug-wise. I don't think there really was. One major difference that we did, though, is in the material itself, the resource data that we load. Instead of loading diffuse color and diffuse map name, specular map name, normal map name, like we were doing before, instead of having those hard-coded named properties, we made a large change to have an array of maps, which is material maps, an array of properties, which is material config properties, right? And then we take the name and the type. So we default the material type to unknown, and we parse that out instead. Here's all of our parsing code. All of this stuff should be fairly self-explanatory if you've watched before. And if you haven't, you know, I would recommend that you probably go and watch those previous streams to fully understand what's going on here. But basically, this is just a bunch of checking to make sure that our opening and closing tags within our material files are sort of in the right place in the file, and that we're not trying to, you know, close a material property when we're not in a material property parsing, things like that. So it's just to enforce a good format. And then some of these things are just sort of the linting or auto formatting. Let's see. Here is where we do the version parsing. So we go ahead and parse that out. Here is the mode parsing for name. So depending on what mode we're in, it'll either become the resource data name, the current map name, or the current property name, depending on what we're parsing at the time. And then most of these things kind of work the same way. So a lot of these things, you know, if it's version 1, then it'll read into diffuse. Otherwise, it'll say, hey, you're on a version of the material file that is beyond 1. You shouldn't be using this anymore, right? And so these are the same. So we're just trying to still support the older versions of our material file without breaking that backward compatibility. Let me go back to the comments here. Just started learning OpenGL, very excited. Currently working with camera controls. That's awesome. Yeah, there's nothing more exciting than, you know, after you get your first triangle on the screen, then actually setting up your camera and like tying that to keyboard input and like moving it around in 3D. I did that for a long time the first time I got it working because it's just mind-blowing when you actually get it to work. It's really cool stuff. And then eventually get to the point where you're writing an entire engine. Okay, so most of this stuff is just parsing the different properties for version 1 or 2+, etc. So I don't feel like I really need to touch on that. A lot of this stuff just kind of makes sense if you read the code, right? Mesh Loader had a few updates as well. There are a lot of formatting updates in here, but actually, let me see. Most of these are formatting updates, which is kind of annoying because my formatting was broken for a while. And a lot of these updates I actually don't like, but I'm too lazy to go back and actually revert them because that's a lot of work. I think the biggest changes that I made were probably around, where is it? The sub-object processing, I want to say. There was a couple bugs in here that I found and fixed. Also this import OBJ material library file, I also had to make changes to that as well. Namely, to split this out into individual properties instead of trying to use the current config diffuse color. If we're, depending on what version of materials we're using, we actually set those things up correctly. So this is now set up to actually import a version 2 material and just hook up everything as if it was read in from a version 2 file. So this was needed because our changes to the material system actually broke compatibility with this. So we had to fix that as well. And so this is just adding the maps, material, or the maps, the properties, and I think that's it. Most of this is actually just formatting changes, which is kind of annoying, but we have a couple of static utility functions down here at the bottom. And yeah, here we go right here. So when we're actually writing out the material file from a material, we are writing those out to version 2 now instead of the 0.1 that we had before. We're also defaulting to Fong. So we should probably, at some point, we'll probably, when we go to update this again for PBR, we'll probably do a type check there and spit out the properties as necessary. But this will get us like 90% of the way there. Okay. So here's all the filter modes, the repeat modes, all that stuff. And then here's where we actually write the properties. And that is that, right? So that is it for the mesh loader, right? So it's actually a lot because of our sort of OBJ file handling in there. We might move the OBJ portion of that out to another file at some point, but for now, that's the way that works. Resource types saw some updates as well. Again, most of this is formatting. I'll point out the important things. So texture use, this enumeration is gone. We don't use that anymore because we weren't actually really using it anywhere on the back end anymore. We kind of refactored this out a while ago. And there were just a couple things that were holding on to it. So we've gone ahead and factored out this texture use enumeration. So anywhere where that was, it's just gone. So you can see here that was removed, right? Looks like a comment update there. And I think that's probably about the extent of things that we removed. Oh, we also moved material config and the material structure to the material system header file because it just makes more sense for it to actually be there than, as part of this resource types file, right? Because if we're going to be using materials, we're going to need the material system anyways, so it kind of makes sense for it to actually be there. And I think that is mostly what is here. Most of the rest of this is just formatting. We do have a new material type enumeration. So our default is unknown. So any zeroed structure will have unknown, and that'll allow us to say, hey, if we're trying to use a material that's been zeroed out or that's invalid, then we're going to throw errors when we come across this unknown type so that we don't deal with, borked defaults and things like that. We have Fong, PBR, UI, and custom. And when we go into the terrain updates, we're actually going to have a terrain type here as well. So here is the configuration for a configuration property. And this does have one major issue with it that I do want to fix. And I did talk about this on stream when we wrote this, but just as sort of a recap here. So we have the name of the property, the uniform type, which is basically like float or float 2, float 3, or for vector and whatnot. The size in bytes, and then the individual values here. Now, obviously, this is a massive waste of memory, right? We could do this as a union or something like that, but these types aren't all the same size either. So basically what we do is we just say for the given type, we load it into the appropriate value, and then we can extract that on the other side. This is only this way in the material config that's parsed from a file. So once we parse it and we stand up the material and throw this out, the memory waste is gone. So it is temporary. I am going to devise a better way to handle this in the future, but for right now, that's kind of how we're doing it. Material map is basically just a collection of the name of the map, the texture name that's going to be used, and then obviously the sampler properties, so the filter and the repeat mode. The material config is a lot simpler. We don't have those hard-coded names anymore. All we have now is the version, the name, the material type, the shader name, if provided. The type can also give us a clue as to what that is if it's not provided. And then a array or a D array of properties, a D array of maps, and then whether or not it should be auto-released when there are no more references to it. So the next thing is we have this material Fong properties and material UI properties. And these are those structures that I was talking about in the shaders on the other side. So these match up to what we have in the shaders, on the shader side, I should say. Now we actually have the material structure. So obviously we have the ID and the type, generation, internal ID, name. These are all things that we had before. Now we have an array of texture maps. We have a property struct size. So that's going to be either size of Phong properties or size of material UI properties, or eventually size of material terrain properties for terrain materials. And so that's that. And then we have an array of those structures here. So we'll just allocate that dynamically in memory, depending on how many of those we have, given our configuration. And that is that, right? So that sort of replaces this, right? And then, of course, we have the shader ID and the renderer frame number, which were there before. And I think that's it for that file. Skybox looks like we just had a reordering of the includes here, and then we removed the texture use. The font system, we had a reordering of the includes again, and again we have removed the texture use. Looks like it's going to be something similar with geometry system with the includes. However, in this case, we fixed another bug where the default material for the 2D geometry was actually using the material system get default instead of the material system get default UI. And how this wasn't causing problems before, I don't know. But it definitely is something that needed to be fixed. So we've gone ahead and fixed that. The material system is probably what also, in addition to the parser, is what also got the biggest amount of updates. So again, we have our include reordering here. Shininess and diffuse color have been removed for properties, right? So there's one uniform location for properties. Same thing with uniform locations for the UI shader. So we have diffuse color is removed. Now we have properties. And then we have a default UI material, right? So we didn't have that before, now we do. So here we've added a create default UI material. Again, how we got away with not doing this before, I'm not really sure. It's one of those things that worked but probably shouldn't have. We have our properties changes here and here for our material locations and UI locations. Here's where we create our default UI material. Again, more properties updates for locations. If we go down a little bit further, so we changed the material system acquired from config to take in a pointer to config instead of a copy of it, because we shouldn't be copying all that data around, right? It's much better to just take in a pointer to that. So a lot of this is just syntax updates to support that change. And then we also have a check here. So our on release, we check the name to say if it's equal to default material name or default UI material name. Then we ignore it, right? Because we don't want to release those. Here is our get default UI. So it just returns the state pointer default UI if state pointer has been set up. Otherwise, it bleats about it. And then... So we've gone from having these hard-coded sort of diffuse, specular, normal maps to our array of maps, which in this case we know as index 0, 1, and 2. That is a known location type for this type of shader, so that's okay to do. But we're getting away from hard-coded names there. Here is also a change for that as well as the property structure. And then... our assigned map actually got some changes as well. So we copy over the sampler data, and we've actually stripped out a lot of the old diffuse logic, or the old property logic, as well as the sort of hard coding these defaults in here to actually reading what is actually configured, right? So that's mostly what this change is. And then load material is also dealing with all of these other changes. So I'm seeing a lot of chat activity. Let me see. You inspired me to. Thank you so much. Keep doing what you're doing. Thank you. I appreciate I appreciate hearing about that. Makes it worth it for sure. I'm glad you're enjoying the series. The heck, YouTube, also nice haircut. I see magic numbers. Yes, YouTube. I'm trying YouTube streaming to see how it goes. It's just an experiment like everything else I do on this channel. I want to see how YouTube streaming works as compared to Twitch. So I'm trying it over here a little bit. This is also going to reduce the delay between... actually, it's going to completely eliminate the delay between the stream and the episode releases, right? Because as soon as I'm done streaming here, the episode is up on the YouTube channel. It's available. So, we won't have to wait till Fridays anymore to have those releases. So that does also mean I'm not going to have Friday releases unless I actually record something separate, like the devlog videos or something like that. But I think it'll be worth it, right? It just kind of takes out a lot of the middle work that I have to do there. So we're going to try this for a little bit and see how it works. Let's see. So you see magic numbers. Magic numbers. I know there's some magic numbers I removed. Unless you're talking about these. So these indices, yes, these are magic numbers for sure. But they're magic numbers that only exist because we are aware of the structure of this material type. So if that's what you're talking about, then yes, there are magic numbers. I could, I suppose, make a define out of it, but I'm not worried about it for now, because chances are we'll probably come back to this code again at some point, and clean it up a little bit further anyway. Excuses, yeah. Well, sometimes a guy just has to move on, I can't spend, 6 months on the material system as much as I'd love to. All right, so I think the rest of this is actually just basically changing over from using those hard-coded names to individual defaults. Should probably be configurable, but for right now, I'm just going to leave it as is, because these were actually the defaults that have been in the engine since day one. So here's where we handle the properties. So we loop through all these properties. We do a string comparison to make sure that we're using default color and shininess. So if you are using a Fong material type, it is going to look for these property names specifically out of your configuration from that configuration file to use here. OBS did not like your connection. What do you mean? Is the video cutting out or something? Or is it? Because I'm not seeing any lag on my side, at least. It cut out for a moment. I wonder why. Okay. Yeah, I'll have to keep an eye out on that, but I'm not seeing... Yeah, I'm not seeing any drops, so... Okay. Maybe it's you, Calvin. Maybe it's you. All right, so... And OBS actually complained, so it's not on my end. Wait, OBS complained? Maybe it's on YouTube's end, but... I don't know. Anyway... so here is the maps. So again, we have expected map names here for this material type. So what we do here is we just go ahead and grab those. And then if for some reason it's not able to get the texture, it just uses the default textures, right? The UI is basically a simplified version of that with one property and one map. The custom version of this obtains a property count, and it goes through the property count, adds up all of the property sizes to get the full size, then allocates an array to hold all that stuff, and then basically jams all of that stuff into a solid block of memory, one value right after the next, which will eventually be fed into the shader as a massive struct, basically. See Discord, I dare you to say it's me. All right. I'm still blaming you anyways. Still blaming you, Calvin. Let me see. What is Discord saying? For those of you who don't know, there is a Discord server. And it is in the description below. So if you want to hop in on the conversation, it is there. I don't see anything in here. I don't have time to actually like scroll through all the channels, but okay. Anyway, I'm going to move on. So, here's where the actual copy happens in the memory. We keep an offset, and we just basically jam those values in one by one. Here's all the maps. So this is where the actual assignment happens. And then this is all the logic that we've removed from this, right? So this is, again, all that hard-coded data where we're making assumptions about texture repeat modes and linear filter modes. We're getting rid of all that stuff. So the next thing is when we are going to send it off to the renderer, right, to acquire resources, we base that off of the material type. So the first thing that we do is we grab the appropriate shader. So if a shader name has been defined in the config, we use that. Otherwise, we fall back on built-in material for material type Phong. UI falls back on built-in UI. And custom does not fall back and will throw an error if you actually don't provide that. So that is where that logic is implemented. Obviously, if you try to do a PBR shader, we don't have those implemented yet, so that's going to throw an error on that as well. A little bit further down, here is where we actually handle the maps. So we create a array of texture map pointers. For Phong, we know that we have 3 maps. We allocate that, and we go ahead and take the address of the material maps for that. For UI, we have an array of 1, right? So we just set that up. And for the PBR, we fail on that. And for custom, obviously, we take account of the map count, allocate an array for that, and take the addresses of those maps. We then take all of those things and pass it to the renderer to say, hey, acquire instance resources for all these things. So it goes ahead and does that. Double checks to make sure that everything is good. So we basically check the result here, and if that failed, we'll spit out an error message and bleat about that. If the maps array was actually created, which it should be in this case, it goes ahead and frees that. And then, let me see. Is this live running in different platforms? You mean the engine? Yes. Yeah, so Calvin's right. So there is code for Linux, Windows, and Mac. So yeah, this is cross-platform. At least cross-desktop platform for right now, the engine. And thankfully, we haven't had to touch the platform layer in quite a while. So some of the features we're going to be implementing sometime very soon are going to have to touch that. But no switch port yet? No, not yet. Actually, I have some plans for some games that I'm going to make using this engine. And one of them I'm designing with the Switch in mind. But obviously I'm going to wind up having to release that on like PC first. And then port it to Switch later. Because that's a whole other thing. Oh, you were talking about the live stream. Yeah, that can be viewed on anything. You can view it on your phone if you want. Okay. So destroy material obviously just does destroy material things, right? There's not really anything exciting to talk about there. Creating the default material, we basically just fill in the new material properties that we have. So obviously we need to fill in the type, which the default material type is Phong. That'll change probably when we put PBR in. The property size and the properties are obviously material font properties. And then we fill out the properties here. And then basically we just use our default textures for our maps here. So we have the default diffuse, default specular, and default normal, right? And then we go ahead and create our texture maps and do the resource acquire, etc. Do the exact same thing for the UI material. This is simpler, obviously, again, because we only have one property here and one map here, right? And that's it. So that is it for that. Here are the header changes that come along with this. So this is default UI, is the default material name for the default UI material. And then I think that's, we just have a getter here basically for the default UI material. The shader system, not a whole lot actually changed in this. I think it was literally just me adding this code for tracing. Oh, and this removing this texture use code. Okay. Debug console. I actually found an interesting error on here where if one of our console consumers actually has an error outputting to the console, it can actually cause this entire thing to fail. So basically, if we have high priority error fatal messages, we don't bother with the splitting of this code, right? And this was part of something I found while I was debugging, basically where I was trying to split memory that wasn't actually a string, right? So bad things happen there. So this is basically just a workaround for that. So if we have fatal either error or fatal messages, that we don't split those things, we just slam them out directly to the console as is. Vulkan backend saw some changes as well, although nothing huge. So basically we just removed this texture use code. And then instead of trying to, like, this was really the only place that actually used that. And we're offloading that stuff to the front end, right? So we don't want the back end to be concerned about texture use at all. So we do have a default here to just get the default texture if we don't have anything by this point, but we really shouldn't ever really hit this. Okay. Okay. Let's see. Just catching up with chat. So you're talking about the live stream. Did you mean, oh, so you meant Twitch versus YouTube, I guess? So yeah, I'm only streaming to YouTube right now. That's not to say that I'm not going to stream to Twitch again, but I'm trying out YouTube for a bit. So this won't show up on Twitch. It'll only show up here. Wait, you debug, you don't write perfect code every time? Hell no. I don't know anybody that does. We need to talk more and make it more difficult for him to catch up. Yes, fill the chat. Not with spam, though. Don't do that. That's not cool. All right. So this is basically where we're at with the material Redux. So at this point, this branch will compile and run, including using a custom material. So that is that branch. The next one is terrain, which I've actually already pulled in the shader work, I believe. Or was that the other one? No, we've already, I think it was this one actually. So this already has all that stuff in place. I don't know if there's anything worth going over in here. So probably what I'm going to wind up doing is between me go back here. So probably what I'm going to wind up doing is between these three, terrain materials is the one I'm working in now. Once we actually get terrains working, I'll merge this back into terrain and then merge that into main. Feature material redux will be merged into main on its own. And so probably the order of operations will actually be material redux, terrain materials will go into terrain, and then terrain will be merged into main. So that is where we're at. Let's see. Yes, I do know what you're talking about, Calvin. Enter into the Discord server that's in the description. Yes, awesome. Not sure if YouTube is blocking me from sending the link. Can you not send it? So that's like one of the things I'm going to have to figure out is like moderation, because I've not really streamed on YouTube quite as much. So let me try. Let me try doing this. So Calvin, I added you as a mod. For those of you who aren't aware, Calvin is actually a mod on my Discord server as well. So that's why I gave him mod privileges here. There it is. I wonder if that's permanent or not. I wonder if that'll stick to the next stream. We'll have to see. Thank you for the Discord link. Cool. All right. So, with all of this discussion out of the way, we can actually take a look at what I have been working on in this branch, right? And actually, I'm going to bring up VS Code. I know, the horror, but VS Code has a pretty good viewer for changes, pending changes, right? So I'm going to use that. Oh, you like the desktop? Yeah, it's pretty sweet. I forget what it's from. I just found it online, but yeah, I like it a lot. And so basically what I've been working on is putting the changes together between the material redux and all the material stuff that we've been doing, and trying to work out the bugs that have arisen from that. And right now I'm having an issue with basically the applying the material system instance of the material type. So I guess I could kind of step through the changes that I've made here to give you an idea of where I'm at. So initially we had this sort of concept of the renderer front end, or the renderer, would treat terrain geometry different from regular geometry. And I ultimately discovered that, and this is as I expected when I kind of put this in, is that I wasn't going to need that. So I've gone ahead and removed that. And in fact, this terrain render data structure is now kaput. We don't use that anymore. So actually, let's step through this first. So we've removed that. And then we removed from the render types the plugin interface. We've removed the terrain geometry draw, because that's just geometry draw now. And then we added to shader instance resources acquire, we've added the map count, right? Because the map count can differ from the number of maps available in the actual shader, right? So we needed to include that. And then a little bit further down, we changed terrain render data to geometry render data, right? And this is in the render view packet. So when we're creating that packet to to throw off to the renderer, we now use just our geometry render data as we did before, pretty much with everything else. Well, Calvin, take another shot because I got distracted from your nonsense. Yes. All right. So we've made front end and back end changes to support that change. Those two changes there. So that's what that front end change is. This one is the removal of the draw, and then the addition of the map count, texture map count, right? So we'll jump to the back end real quick, where we have removed the geometry draw, and we've gone ahead and added the texture map count to the acquire resources, instance resources. The back end has changes to reflect that. So we've removed this, which is mostly duplicated code anyways. So goodbye, see ya to that. And then here we just kind of fixed a formatting foobar that exists. This is currently the section of code I'm debugging. And then here we've gone ahead and instead of using the instance texture count here in this loop, we're using the texture map count. So this fixes a bug where we really should only be moving over these texture maps as many maps as we actually have. We shouldn't be doing it for all of them because they might be just a null pointer, right? And so I've commented these out. They'll probably wind up getting removed at some point. And then I just updated these to be formatted according to our single line format. And then also this instance texture maps, we're only copying the texture map count, not the instance texture count. So I can actually remove that. And then here we just loop through that, making sure that the map exists first. Let's see, I think this is just a formatting change. So that's all that is. And then this is also just a formatting change, just to make it a little bit more readable. Okay. So the material system, we have a default terrain material name just called default terrain, right? We have something in here to acquire a terrain material because the way that this is handled is a little bit differently. So the way that this works is what we essentially do is we have a material name that the terrain material is going to be. And then we have a number of materials and an array of material names. And then, of course, a flag for auto release. And the way that this works is it basically goes through and uses existing materials with those names, loads them up using our existing material loader logic, and then takes the properties and the maps from those things and applies it to a terrain material, which acts as a sort of multi-material. And we can do that without having to keep an array of pointers to materials. We basically just take a copy of the maps, take a copy of the properties, and it becomes its own sort of material, right? And that allows us to reuse a lot of the existing logic that we have and not having to, write a special parser for that type of thing. So in the material or in the terrain file itself, all we have to do is specify what material names that we want to use for each material on the terrain, and then this goes ahead and hooks up the rest. Okay, one missing there. And then, what is with my OBS? What are you doing, you dingus? Did that just drop for you guys? So I'm streaming using, pause for a second. That's it. Okay. That's really strange. Okay. So I'm wondering if there's something going on with YouTube, because I know there's like a connection option in OBS to like connect your account instead of using a stream key, and I was using a stream key. So maybe it's that. I'll have to experiment with a different option next time. I don't want to do it now because if I do it now, it'll interrupt the stream, and I don't want to do that. So I'm just going to make a note of that. key to connect. All right. Did it before, screenshots for proof. Okay, I guess I didn't see them before. I believe you now, because I happen to actually look up here and see them. All right, so we have a getter for the default terrain material, which is obviously going to be necessary for terrains that we're not able to find the default, or we're not able to find the material for, rather. The C file has received quite a lot of updates. Most of these updates are having to do with these properties changes, where again, we've removed the hard-coded properties and the hard-coded maps, and we're just actually specifying the properties instead, right? We also have the samplers array here, which is the same as before, I think. We have a default terrain material that was added here. Obviously, we have our terrain locations and our terrain shader ID, just like our other two types. We have a create default terrain material. I went ahead and forward declared assign map here so that I can use it in a couple of other places as well. Here is where we sort of, let me adjust this over. Here's where we sort of declare some defaults for all of our terrain locations, our shader locations. Here's where we create the default terrain material. That seems to be working, so that's not the issue that I'm having at the moment. Here is where we go ahead and get the shader locations for those uniforms, right? As well as for the samplers, right? So we go ahead and get all those. And then there has been a change to the way that we acquire terrain references. I'm sorry, material references, because we actually had 2 entry points now to obtain a material. We have one to acquire a material and one to acquire a terrain material. And they were both going to need the same hash map, lookup, reference logic, all of that. And so that got split off, that section of it got split off to this acquire reference, where we pass the name of a material, auto release, and then a pointer to a Boolean as to whether or not we need to create a new material. In other words, if we go to do a lookup in that hash map and we determine that we don't have that material and we need to create one, then we would set this to true, otherwise it would be set to false. And so that's what all of this does. So you can see here it's set to true if we are in this block here where the ref handle is invalid ID, which means that there's no material. And then otherwise it's false, right? And then we update the hash table, and then the acquire terrain material, I'll come back to that because I want to touch on this one first. So we have this material system acquire from config. This was the initial only point that actually existed. So the first thing is we check for default material, default UI material, default terrain material, and if those names match, we return the appropriate material. Otherwise, we go ahead and we have our needs creation. We go ahead and do a lookup on the reference. And then if we need to create, in this case, we create a new material, which is just this load material, right? And then we update the generation and then return the material. So this is for normal materials. For terrain materials, we have to do a little bit more work. So terrain materials, again, we look for the default terrain name. Whether or not we need creation, we look it up to see if we get it first. And then if we do not, for some reason, return a material here, then we bleat about it saying, hey, we weren't able to acquire a terrain material, right? We should at least always be able to acquire material, whether or not we need to create it or not, right? So if it needs creation, we are basically implementing our own version of load material here that's custom to our terrain materials. So remember, our terrain materials are sort of a collection of all the material data from different materials, and then those properties and maps are just copied over to our terrain material. So here's where we get all the materials by name. So we loop through each one of those names, grab the material, and then we go ahead and copy over the material name, get the shader, set the type. We allocate the maps and properties memory, right? So we have the properties array here. We have the number of materials here. And then we have three maps per material right now. That's making some assumptions for Fong materials, right? Right now, all terrain materials are Fong materials, or Fong multi-materials, if you want to think of them that way. Eventually, they'll probably be PBR. Like once we put PBR in, we'll probably remove the Fong logic, or maybe switch on it, something like that. But for right now, we're just sort of making the assumption that it's Fong. So in this case, we make an array of map names and default textures for those things. So we automatically retrieve the defaults, and these line up on the index with each other, right? Then we go through our Fong properties and maps for each material. So for each material, we say, okay, we have our Fong properties, which we get a pointer to, and we set the default color and shininess of that to the appropriate material that was passed in. And then we loop through our maps, and for each map, we create a new material map config, copy over the name, copy over things like the repeat UVW, min, magnification filters, the texture name, we go ahead and set that, and then we call assign map again, and that just kind of does all of the magic under the hood for us. And that is where we basically use our flat material maps array. We basically do some logic here to say, okay, well, the index is I for the material times 3, right? Because there's 3 textures per material. And then J is the actual map index, right? So 0, 1, and 2. And so this gives us the appropriate offset. We pass in the map config, and then we also pass in the appropriate default texture at index J. Excuse me. Time for me to make cool drinks. Excuse me. Voice is giving out, apparently. All right. Reborn as a vending machine, I now wander the dungeon. That's an entire anime? That's crazy. Well, good luck with that. All right. Okay. So we have our maps assigned. And then we acquire instance resources for all maps. So we go through, create our maps array, take pointers to each map, and then call renderer shader instance resources acquire on each one of those things, right? So we just pass through the array of map pointers and and obtain that. What is with my voice? All right. Oops, I accidentally commented that out. That should be there. So we clean up the maps array here. And then this is basically the end of our terrain-specific load material function, right? And then we increment the generation and return the material. So that should be it. First episode released today, and I was so WTF, I was like, yes. I might have to look this up.
All right. So that's acquired from config. We've already gone over that. Here's the get default terrain. That's pretty self-explanatory. We'll skip that. Here is, so this logic here is for apply instance. Here's where we apply for the shader type of material. So we apply the maps, the properties, and then things like the directional light and point lights. Now this is a duplicate of the logic above here for directional and point lights. So we're probably going to want to combine that into like a private function or something, but see ya, Calvin. Thanks for joining. But yeah, for right now, this is what we're gonna stick with. And then we have, let's see, I think this is just the number of lights, right? So that's all stuff we've seen before. It's just kind of done again for terrains. And then we can skip all the way down here. We added map count, and actually a lot of, we added this in a few places where there was this render shader instance resources acquire. We just had to add the map count to a few places. So that was one of them. This is another for the built-in material. We know that's going to be 3. For UI, we know it's going to be 1. And then here's where we'd create the default terrain material. So in this case, we essentially build a material that only has one material on it, right? So we just build that out using the default diffuse, specular, and normal textures. And then, of course, we have our texture maps array, and we go ahead and, whoops, wait a minute. 3 maps. No, okay, that's fine. So in this case, we know we're going to have 3 maps because we only have just the one material in our multi-material, and then we pass maps, right? And that is basically all of the changes for that. All right, so excuse me, I don't know what's going on with my voice tonight. All right, this is just another one of these. Terrain. Basically just remove this because we don't really need it. That is covered by us adding the properties and maps to our material, right? So we don't need that. And then this I wound up moving elsewhere. So this is just, I believe, just the removal of materials. Yeah, this is just the removal of the materials array. And then the acquisition of materials is no longer needed, right? We don't need to do that anymore. Instead, what we do is we just say material system acquire terrain material. So this is that new function that we wrote in our material system, and we just acquire it here, right? So this plugs in just as if we were using any other material. It gets assigned to the geometry material when we load up the terrain. So this is the reason that we could get rid of that sort of terrain render data and all that other stuff. We don't need that. Skybox just had a small update. Again, for the texture or the instance resources, we just needed to provide an account. Everywhere that used terrain render data, switch to geometry render data. Excuse me. I'm drink some more water, apparently. Apologies for all the coughing. I don't know what's going on with my voice. Feels like it's about to give out on me tonight, though, so I may have to end the stream early. Hopefully not, but... All right, so we replace our terrain render data with geometry render data, and just update our geometry here with the terrain's geometry. So again, we're just sort of simplifying and reducing the extra things that we have to add here. Let's see, we already went over that. I think most of the rest of this stuff is actually going to be pretty self-explanatory. Again, changing to geometry render data for the world data for the world render view. We've gone ahead and stripped out all shader location information from the world view, right? So we took out all of this stuff that was setting terrain locations or terrain shader data from this, and we offloaded all of that onto the material system, right? So all this stuff here, all gone, right? It shouldn't have been here. We were sort of doing that as an experiment to see how it was going to come together. Now we kind of know how it's going to come together. So none of that stuff belongs there. So it's not there anymore. So this here is basically just getting rid of this to render terrain. It says use the appropriate shader and apply the global uniforms. And I have a note here that says if we use a custom shader to try and render this, that is probably going to fail. Because of all of the weird maps and stuff like that. So there are some things that are being done here that we're probably going to have to come back and revisit. Okay, so here we're doing the render of the render packet. We are looping through each one of the the terrains, and this is where we're applying the individual terrain properties, right? So in this case, we have material, and we have an empty pointer to a material. We're checking to see if the terrain geometry is at sub I, the geometry material is set. And if it is, we're going to use that as a material. Otherwise, we're going to use the default terrain material. Here we just updated the warning message, removed a whole bunch of this other stuff that, again, should be done by the material system. And I think that's it for that. The pick shader, or the pick view rather, just needed these counts, which we don't have any maps for that, so we don't use that. And I think that is actually all the changes that we made so far. So with that, where we are at now is I'll just go ahead and build this, and it does build. And it does run, but I'll show you guys where I'm currently debugging. So if I go to load a terrain, right, we can tell from the delay that it loaded up all the vertex information, it loaded up all of the material information, but when it went to actually go apply that, that's where it's actually falling apart. So this is kind of where I'm stuck and debugging at the moment. So I figure this is probably where we're going to wind up picking up. So more than likely, what I'll wind up doing is just keeping mind of the time is I'll debug this for a little bit, and if we don't get it here, I'll push these changes up to that branch, and then I'll probably wind up figuring out the rest of it off camera, right? So one of the things that I ran into that kind of kept me from progressing any further with this was I had a lot of technical issues on my machine. So I made the mistake of last week updating, doing a pretty major update on my OS, and one of those updates was a new NVIDIA driver, and that did horrible things, and it took me forever to get it rolled back successfully. One of the downsides of using Arch, for sure. It was much harder to fix, but I fixed it, so here we are. Anyway, so what is basically happening here is if we look at the texture here, the address of this is rubbish, right? Like this is just garbage, right? There's no values in any of this. Like there's not really anything here, and that's why it's failing, right? Because it's trying to check generation on something that's not really a valid pointer, right? And so if we take a look at map, we can see that the map is foobar too. So the texture on the map is just this, which is garbage. the minify, magnify, like all of this stuff is just garbage. So we have to figure out why we're not getting a proper map here from this, because this is working otherwise except for terrains, which is sort of the issue that we're at. And so what we're doing here is we're getting a pointer to the map from the internal instance states. And for reference, this is in the Vulkan backend, right? So we have the instance states at the bound instance ID, which the bound instance ID is 1, which does make sense because this particular shader instance, we would have already created a default terrain material, which would be instance 0. And then we've created, we've loaded up this configured terrain instance, which would be 1. So we know that. And then the instance texture maps, we should have basically an array of 12 of these that exist in memory. And then we're trying to access the one at sub I, which is index 1. Okay. And so if we look at, I've got basically this line of code here. And if we look at sub 0, right, we have texture and we have texture data, right? Like, looks like this is sort of a default texture, right? In fact, if we expand this, we see that it is default diffuse, right? So this tells me that we have a default texture on, oh, that's interesting, actually. So it looks like it's loading up the default material. So if we look at index 1, we see it's rubbish, right? So I guess I probably ought to look at, let's do part of this. Let's actually look at the state itself, right? Let's add a new one. And we'll look at internal instance states at the bound instance ID. So ID 1, offsets, descriptor sets, descriptor states. It's going to be index. So these are all invalid, which points to a default material. So why would we be getting a default material at this point? So let's actually expand this a little bit and walk up our stack. Here, our function stack. And yes, I realize I'm using VS Code's debugger, which is another change I meant to talk about on stream. So I am going to be switching back to VS Code for debugging because the debug setup that I have in Vim is it's kind of suboptimal, right? It's not really great. It doesn't resize it doesn't respond to window resizes all that well. And so until I figure out how to make that work a little bit better, I'm probably going to continue debugging in VS Code. So just sub note there. Okay, so this is where we're applying the instance. Material system apply instance. So let's have a look at what material we're actually applying. So we have material M, ID 0, material type terrain, generation 1, internal ID 1, the name of said material is terrain mat test terrain. Okay, so it looks like we are using the default material somehow, even though the material that's defined here is terrain mat test terrain. So The material shader ID is 2, which is the one that I happen to know is not this one, is the material shader ID, right? So we're falling into this. This makes me wonder if when we go ahead and retreat, oh, you know what? Let me look at something. Default terrain material. Let me see. Let me see if at any point we're calling this. Interesting, we're not calling that. So that's very strange. So when we create the default material, let me see what we're actually doing in terms of the material name. Do we not? Oh, here it is. Default material name. So we are assigning that. So when we're loading up our material, for some reason, we're getting like the properties as if we were loading the default material. I wonder. Yeah, I don't see anything in here that is pointing to us doing anything weird. So I'm wondering if we're doing something wrong in here, where we're just winding up with default maps somehow. Joshua, welcome. Welcome to the stream. All right. I think I'm just going to step through this logic because I don't see anything here that's glaringly wrong. Talk, hello, welcome. How are you guys doing tonight? Well, I hope. Let me see. So, trade material properties, structure size is 84. That I think makes sense. 84. Actually, I want the... Let's see, properties. I have 144 here. That might be part of the problem. That might be part of the problem. We'll come back to that. Because it should at least work, even if that's offset is wrong. Okay, so we allocate our properties array. cast that to a known type. Set our number of materials. Our material count is 2, which is consistent with our setup here. So that should give us 6 maps. And then we set the array to that, to have that length. Map names is 3. So we have a diffuse, specular, and normal for each. Go ahead and grab the default textures for those. Those should all be valid. All right, that one is, and that one is. And then we're looping through the materials. Here's the properties. Wait, this doesn't make any sense. Map props diffuse color equals map props diffuse color. What am I doing here? This should be materials. Oh, what a dingus. Okay, let me change that. This should be materials. Sub I. Wait. Material properties. Right. Actually, I need 2 of these. Props equals the address of. Actually, it should just be materials sub I properties. And then this should be props diffuse color and props shininess. I wonder if I did that elsewhere. That might be part of the problem. Yeah, because I was just like copying it into itself, which makes 0 sense. Okay, so the maps, loop through each one, create a map config. We have our map names, which is passed in from here. So the name is copied there. Materials sub I. So we're copying this correctly. Materials maps sub J, which should be here. So that looks correct. So this is just taking a pointer to that. And then we assign to the material maps. Excuse me. And all right, so let me actually debug up to this point. So we'll load. I can get rid of this because we've confirmed that that's all good. All right, so map config name. Is diffuse. Okay, so that seems to be working correctly. So we have the repeats set up. The texture name is, ooh, that's empty. Why is that? That's still good. Okay, what am I copying that from? So we have what? I is 0, J is 0. Okay, so if we go materials, and then maps, and then texture, name. How does that texture name not exist? Channel count is 0. This is all 0, actually. This is all zeroed out, except for the generation. I guess because we haven't loaded it. It's the only thing I can think of. But we should still have a name. Let me see our materials array. So the very first one, the maps texture, sure enough, doesn't have a name. That's very interesting. So let me look at this whole array. It should just be too long. So here's our two materials. So the first one's a Fong material, which is just floor. Its maps has a default texture at the moment. And then another Fong material, cobblestone. That one actually, oh, that's the material name. Look at the map. Material name is also 0. Okay. So I'm thinking this might be where it's falling apart because we don't actually have a texture name to actually look up at this point. So look at material names. So we have, floor and cobblestone. We should have, I think those are valid materials. Let me see. So we have floor. This is version 1. That should be fine. Unless maybe this isn't working correctly. And then cobblestone. Which definitely has texture names. Okay. I'm not sure if that's a red herring yet or not. I guess we'll find out. Doing pretty good. Glad to hear it. Glad to hear it. All right, so we assign the map. So I guess let's go ahead and step into assign map. So we copy over all of the config properties. So those are correct. Texture and internal data aren't set yet. So the texture name is an empty string. So that's where we're getting the default texture from. And the default texture Okay. So that actually makes sense as to why we're getting that. I don't understand why we're not getting the texture name out of the config. This should be a fairly straightforward thing, I would think, unless I'm missing something in the parsing. So when we acquire the map resources, let's see. We set all this up. Yeah, I'm pretty sure this all works correctly. Do you find yourself having to step through the debugger a lot? And is it memory related stuff that might take up as much time on a higher level language? Just curious. I'm making my own little OpenGL renderer using LearnUpGL and your videos in C. So I don't actually struggle with memory issues too often. The only time that it's really kind of a pain is when I'm doing things with, void pointers and casting. Sometimes I'll cast it like the wrong structure type or something like that, and that can mess me up because there's not really stuff that gets caught by the compiler there. But more often than not, it tends to be because I thought I set something somewhere and I didn't. And then there's some weird default value that sometimes works and sometimes doesn't. But yeah, I don't find myself I don't find myself debugging a lot anymore really with memory issues too much. Sometimes certainly yes, but might not take as much time in a higher level language. There's other things that can cause you to take more time in higher level languages though. So where you might not have to mess with memory as much in something like C#, there are other issues that you still have to debug that you wouldn't necessarily have to worry about here, like trying to work around the garbage collector and stuff like that. Yeah, logic errors that happen in any language. Yeah, more often than not, that's usually what it is. All right, now I'm beginning to think that I've done something in the parser that's just not right. I will say C is easier to debug than C++ in my experience. Any day, absolutely yes. Much easier to get stack traces. Also agreed. Yes, 100%. Okay, so config texture name, material map. So assign map. Texture name, materials, maps, texture name. My question is, so we saw even when we had these materials acquired here, that they didn't actually have the texture names in place, which is very bizarre to me. So if we do material system require, you know what, let's step through that, because I want to find out how it's possible that we're not actually getting texture names in the material system. And I wonder if it's something that I've changed with the parsing. So resource system load. Let me skip over that for a second. And resource.data. And we're going to pass through the material config to acquire from config. So let's take a look at this config here. You know what? Let's actually do this. All right. So we have name, floor, maps. The name here is diffuse, and we do have a texture name here. So we are parsing it correctly from the file, at least. Okay. So that is something. Okay. So let's go ahead and get that material. Pretty sure we're going to need creation here. Yep, we are. we'll load this material. In this case, we will say, take the name, take the type. Let's see. So the config type is fung. So the properties here are the maps. So I'm actually going to skip ahead to maps. We have darray reserve 3. That makes sense. Map count, I could just say 3, but all right. So we loop through that. We get the diffuse. Let's go into assign map. Let's see. So the map that we're given, zeroed out as I would expect. The config that we're given does have a texture name. So we do have a texture name here. We do texture system acquire on the config texture name. I'm just going to bounce over that real quick because I'm pretty sure that should work. There it is. That is actually where the problem is. So this should work, but it doesn't. Okay. So it's actually here. Because we've never actually used textures this way before, I think this is part of where the problem is. So in process reference, we're doing a hash table get. If we do find it, we just increment the reference counts. Let's see, where is... Oh, okay. So if reference count is 0, so we're loading a texture for the first time. Thought you were going to take a 2-week break. I kind of did, but I also kind of didn't. So I took a 2-week break from actually streaming, but I didn't really take a full break on this. I had a bunch of other stuff that I had to do IRL, so to speak, but I did actually work on this a little bit. I just tried to kind of step away from it a little bit to give myself a breather, and I think it was enough. Let's see. So reference counts, texture. Okay, so this is if we're decrementing. So we want the increments. This means no texture exists here. So here we go. So this is where we're generating the ID, the texture, the type. Here's where we actually load the texture. So we should probably be setting it somewhere in here, and we're not. So the name, we should probably be doing, let's see, skip load. I guess we could do it here. We'll say t name equals string duplicate name. Oh shoot, that's already a character array. Okay, so we can't do that. We'll actually have to say string copy or ncopy. And then we'll say t name. The source is going to be name, and then texture name max length, which I think is only actually, oh, it is 512. Okay. make sure to hold onto the texture name. Okay. I wonder if that will fix it. Let's see. So I'm actually just going to load this material. And we'll just have a look at it real quick. Maps, texture, name. Hey, we have a name now. Okay, so that means that the texture lookups should actually work. So I'm actually just going to go for it and just press F5 and see what happens. In fact, I'm just going to take off this break. Actually, I want to disable that breakpoint. I don't want to get rid of it. Looks like it still failed. That's cool. But why though? Okay. So let's turn this breakpoint back on. Relaunch. All right. Map config name. Okay, and then texture name. So texture name is populating there now. So now we have assign map. Copy all that stuff over. Config texture name is Sponza floor A diff. We will acquire that texture. That doesn't look like it worked. At all. Oh wait, yes it did. Okay, it's just not loaded yet. All right. So Sponza floor A diff. Okay. And then if not map texture, which we do have that, so that's not an issue. Okay. Texture map resources acquire. Let's just make sure that this is doing what we expect it to. This is just assigning all of the properties. We're going to create a sampler. Let's see. Okay, so that was successful. The formatted name, Sponza floor A diff text map sampler. Okay, so that's just a debug object name. That's fine. We'll turn true. All right, we'll go ahead and do this for the next map as well. So let's just take a look at this map config. So this is the specular. So it looks like we got that. We'll go ahead and make sure that the texture acquisition works for this as well. Okay. Looks like it did. It got the default. I'm assuming it got the default texture again. Or it's using the default texture's data, but we do have the right map name here. Okay. Okay. So let's actually have a look at M maps real quick. And let's just make sure that our two have loaded up successfully. So this texture is Sponza floor diffuse. Okay. And then sub 1, Sponza floor spec. Okay, so that at least seems to be hooking up correctly now. All right, so I'm going to assume that this last one's going to work too, because that is the normal map. Wait a minute. Oh, right, we have 2 materials. I suppose we probably ought to verify that those work. So properties, materials. Let me take a look at the first. Whoops. Properties, materials, sub-0. Okay, so that's properties. We don't need to worry about that so much. Materials maps. So materials maps, actually, we should be loading into index 3 now. Let's see, materials. Yes. Okay, so that loaded in. We do have a texture. Let's see. Cobblestone. Okay. So I think we'll just might as well just check 4. Index 4 rather. That looks like it's valid. Cobblestone spec. Okay. All right. So I'm going to assume that the normal map is going to work as well. And we'll just skip over that. All right. Now, we've assigned all the materials. And then we're doing this free here of the materials. Size of material times material count. All right. So I wonder if... No, this all seems fine because it took copies of all this stuff, so that's fine. We don't have any aliasing going on here. So now we're going to take maps. We're going to take let's see, do we have a watch here for maps? We do not. So maps. This is going to be an array of 12, potentially. Right, so this looks fine. Yep, okay. So that I think is going to be fine. Okay, so filled out the first. Wait, why did it fill out? Why did it fill out 6? Wait. What? Am I going... what? I'm gonna relaunch this. Just want to make sure that memory was zeroed out before anything else. Should have been. Okay, so we allocate that times map count. Right. Actually, yeah, I think this was probably correct because this is considered garbage from here on out because we don't actually have... We only have 6. So actually, yeah, okay, that actually does make sense. Never mind. All right, so we'll continue past that. It only updated those. Yeah, that makes sense. Maps times map count. That should be fine. The only thing I can think is something in here where we're acquiring these resources is just not right. let's see, we found that. Instance state. Instance texture count is 12 because we can have 12 of those. Right? We allocate space for 12 texture map pointers. All right, default texture, that's fine. So we copy into the instance texture maps size of texture map pointer times texture map count, which should be 6. So we should be able to say all of this. Let's look at look at it as if it was a 12 element array and just see what gets copied in. Spawns a floor diff. Spawns a floor spec. Spawns a floor normal. Okay. Let's look at the second one. Cobblestone. Let's see. Name. Cobblestone spec. And cobblestone normal. Okay, so these are all correct. And then these are all zeroed out. So that is doing what I'm expecting it to do. So I don't think there's an issue there. I wonder if... Okay, that didn't do anything, which is what I expect. UBO stride is 640. Okay, this is just for UBO allocation, so I don't care about that. Descriptor bindings. Don't care about those. We can actually skip most of this stuff. Allocate descriptor sets. So at least at this point, the instance state, instance texture maps are correct. The instance state is for 1, which is what we then look up later, which then seems to be foobar. So we have bound instance ID 1, instance texture maps, right? So if we take all of this stuff, actually I think that's what this is. Yes. Instance texture maps. Didn't I already have that here? Instance texture maps. So we'll say treat that as an array of 12. Yeah, and all this is rubbish. Oh, wait a minute. That should be... It's because I'm looking at index I. Okay. So these are all zeroed out from 6 on, which is what I would expect. Let's look at index 5. Texture, name. Okay, that looks correct. Instance texture maps. Sub 1. Okay, and then wait a minute. What? Sponzo floor diff. So the first one is correct, but the rest of them got wiped out. What is this one? Same thing. Rubbish. This might be one of those this actually might be one of those memory issues I was just talking about. I don't run into all that often. Let's see. No NeoVim. So I am using NeoVim for editing, but for debugging I'm using VS Code because the debugger in VS Code is way better. Unfortunately. I tried to make it work in NeoVim, but there's a lot of issues with it. So boy, I just looked at the time. I'm actually over in terms of time for the stream tonight. So, yeah, we're not going to get to the bottom of this tonight, but I did at least figure out some issues. So I think once I find this, it's probably going to be a relatively small change. So, let's do, so I'm going to check all this stuff in. Git, add, it's commits, work in progress, material texture map changes. I'll call this number 3, right? That's because I did 2 other commits under that, I think. And then I'll push this up so that you guys can actually have access to it. And there we go. So we'll go ahead and pick up this next time. Next time we stream, I might stream tomorrow. I think I'll probably wind up streaming tomorrow. We'll see. And then yeah, we'll go ahead and pick this up then. And thank you guys so much for watching and following along. And I will see you guys next time.